Maximizing genetic gain is one of the focal points of a breeding program. But how is genetic gain calculated? Today we will demonstrate this by means of an example. Let's first repeat the formula used to compute the genetic gain, which is often also referred to as the response to selection per year. The response to selection, denoted as capital R, is computed as the product of the selection intensity I, the accuracy of selection RIH, and the genetic standard deviation. Finally, the genetic gain per year is obtained by dividing the response to selection by the generation interval L in years. Let's consider the following example about running speed in horses on a 2,000-meter long track. In this case, the breeding goal is the racing time across 2,000 meters. Let's assume that we select the 10% best offspring for breeding. The genetic standard deviation is 3 seconds, the accuracy of selection is 0.24, and the generation interval is 10 years. Now, the question is, what is the value of delta G? As a first step, we compute the response per generation, assuming that the accuracy is 1. Now we need the value of the selection intensity, given that the proportion of selected animals is 10%. In a table that gives the selection intensity as function of the proportion of selected animals, we can find that this is 1.76. Considering the value of the genetic standard deviation of 3 seconds, we can compute that the response per generation is 5.28 seconds. As a second step, we replace this accuracy of 1 by its actual value of 0.24. Keeping the other input parameters as before, we now get a value of 1.27 seconds per generation. So we can see that having a relatively low accuracy of 0.24 yields a relatively low response compared to the maximum possible response with an accuracy of 1. As a third and final step, we want to compute the genetic gain per year. This involves dividing the response by the generation interval. In this case, this is 10 years. So, finally, we obtain that the genetic gain is 0.127 seconds per year. So in this example, the assumed selection approach is expected to decrease the racing time in 2,000-meter races by 0.127 seconds per year.